Hi, this is Gabrielle Principe with This View of Life, the online evolution magazine. I am here at a meeting funded by the AERA. The meeting is Evolutionary Perspectives on Educational Research, Policy, and Practice, and I'm here with my colleague David Sloan Wilson.
Hello.
And we are having a conversation with Dave Bjorklund. Dave just gave a talk entitled The Adaptive Values of Cognitive Immaturity, Applications of Evolutionary Developmental Psychology to Education. So Dave, I'd like to ask you to tell us some of the basics of your talk. What did you chat with us
Thank
about?
you very much. I'd be pleased to. The basic idea of my talk is that children evolved to learn, acquire knowledge, survive essentially in a social environment. But the techniques, the abilities to adapt are maybe specific to infancy and childhood. That they're not just little adults that just need to become more mature and grow up, but they're adapted to the niche of childhood and infancy. And much of this adaptation deals with how they learn, the information they acquire. And some things that we consider to be immature cognition, immature thinking, things usually we hope they get over them fast, are actually adaptive. They're ways that children can acquire information more readily, prevents them from some information from interfering with other information, and it facilitates the way they learn. As educators and sometimes as parents, we sometimes want to get them through this a little faster. Wouldn't it be nice if they could be smarter sooner? Well, yes, in some sense maybe it would be, but that's not the way the human brain develops. It's not the way the human brain evolved. And so giving children small pieces of information as opposed to larger chunks of it really facilitates their learning. Not overstimulating children makes it easier for them to learn. And this, I suppose, isn't all that profound. But if you take a look at some educational practices in the U.S., you wouldn't know this. There are programs, formal programs, informal programs, things on the internet, things you can buy in toy stores and whatnot. How to teach your baby to read, flashcards for infants, DVDs for 6-month-olds. It's all well and good in terms of the intentions of parents, but do these things really work? And it turns out, despite the claims of on the websites and many please parents, that when you do a scientific assessment of them, these programs don't help children much under 18, 24 months of age. There's some evidence these programs may actually hinder development a little bit, but they at least don't help them. And when you extend this into formal education, by formal here I'm meaning with 3 and 4-year-olds, preschool. We're not talking about first, second grade yet, but preschool. Preschools are good. Children benefit in our culture from attending a well-organized, high-quality preschool, particularly at-risk kids who may not have the advantages at home. But what is high quality? There is been a movement, particularly in the U.S., over 20, 30 years now, of giving direct instruction to 3 and 4-year-olds, much like they would get in traditional first or second grade. And it has some immediate benefits, it seems. But as opposed to this, there are folks who believe, and I'm one of them, consistent with my evolutionary perspectives of how children's minds evolve to learn, a more play-oriented, developmentally appropriate type of preschool setting. This doesn't mean you just have your kids out there and let them do whatever they want. There's still structure, there's still some teaching going on, but as opposed to direct instruction, it's more child-centered, more play-oriented. And these programs seem to be as effective immediately in terms of acquiring important intellectual academic concepts as direct instruction programs. There's some evidence that they actually, children going through these programs show advantages several years up the road academically. But the biggest difference seems to be in what we call psychosocial development. Children attending the developmentally appropriate programs a few years up the road, both immediately and a few years up the road, show less stress, more creativity, they like school better, and in general, these programs seem to be most beneficial for children.
So give us the example of the quail, which really sets the stage. So here's something that a kind of interference that we know happens in this particular experiment, and it gives us something to think about with respect to human development.
Sure. The quail study was done by Rob Licklider some years ago, and the purpose of the study was to see what happens when you give an animal, in this case a quail, extra stimulation. Now, extra stimulation would seem to be good. Here the extra stimulation was visual stimulation before the quail hatched. Cut a little hole in the top of the shell, showed them some visual patterns, visual stimulation that these animals don't typically get, but their eyes are working. At least they can work somewhat. And you compare this, of course, to a group of quails that don't get the stimulation. You then put them in an auditory discrimination task. Now here, what quail babies do, as well as ducks and geese, when they hear the call of their mother, essentially, the quail maternal call, they will go to it. They seem to know it. Well, these quails that had the extra visual stimulation didn't. They were just as likely to go to a chicken call as a quail call, and most of the times they just sort of stayed around in the middle of the test chamber, not knowing what to do. Giving them extra stimulation interfered with their normal auditory development. Now, I should say that these animals were better at visual discrimination. It made a difference. But what the difference seems to be is this extra stimulation facilitated the development of their visual cortex at the expense of their auditory cortex. And so basically, when you get a species atypical experience, what the species normally does not get, you get species atypical results.
And so the analog would be is that if you try to teach children things too early, basically, that might interfere with some of their normal development, right?
Exactly. But this is not my approach here. Or, it's not to just leave kids alone and don't try to educate them at all. Don't try to give them any extra experiences. But do it at an age-appropriate level. Don't expect your 2-year-olds to be identifying flashcards of Picasso versus Monet, because it's probably not the type of learning that is most conducive to them. And that yes, maybe you can teach some aspects of complex cognition to very young children, but there's probably going to be an expense to that. First of all, there's very little evidence that you can. You really can't teach your baby to read. But to the extent that you can be successful in improving some aspects of early cognition with direct instruction, there's probably going to be a downside to it as well.
Well, talk a bit too why too much too soon is bad. So extra experience too early on can be a negative thing because it's species atypical experience. But talk a bit about your ideas about how childhood itself, this extended period of immaturity, is a good thing
Well,
for humans.
the humans have a longer period of childhood from infancy up to adolescence, let's say, than any other mammal. It take a long time to become adults. And some people say, well, that's just because we live a long time. It's just, get over it. It's just something we have to live with. But it seems to me, and not just me, many other people, that this extended period of time gives us time to learn the social complexities, particularly the social complexities of life, but a way of learning that a more advanced brain, a less flexible brain, a brain who was more mature too soon, just wouldn't be able to handle. So the extended period not only gives us more time to learn the complexities of social life, and maybe technical life as well, learning to use tools and whatnot, but also the abilities to acquire this information very quickly, very efficiently, before the brain is too set in its ways, so to speak, making it difficult to acquire some of the very new radical types of things we think of. Think of language. Language is special, quite clearly, but young children acquire language for the first and second very, very easily. It's very flexible. But once you get 7, 8, or 9, or 10, it's hard to learn a second language. And you might say, oh, isn't that too bad? Too bad we can't have the flexibility that, when we were 10 and 12 or 20, that we were 4. You don't want your brain to be that flexible for getting a new language at 20. It's too important. Things have to become well organized and very efficient at some point in time, but not too early.
How about individual differences in these kinds of maturation? Have you thought about that? Why is it that some people will do these things sooner than others?
Well, that's a very good question and a complicated one. Some of the individual differences, I think, are related to environmental factors. So the amount of language we receive affects not only the number of words we hear, but the number of concepts we acquire. It affects us both knowledge-wise, conceptually, as well as strictly language-wise, and this can influence other systems, can influence how our short-term memory, our working memory. So part of this, these individual differences may be related to the quality and quantity of early experience we have. Some of them may be more related to more physical, genetically related maturation factors. And to what extent do these differences in rates, so to speak, of how long you become immature affect individual differences? Well, there's some evidence, and whether it's genetically determined primarily or environmentally determined, we don't know, that very high IQ children that end up, as young adults having very high IQs or have very high IQs at age 12 or so, their brains mature less quickly. At least the childhood to young adult period, their brains go through a more prolonged period of what you would call sort of the childhood brain style before it becomes adult. Children with average IQs make the transition in terms of the number of connections they have between various parts of their brains a little quicker. And this increased time may be associated with increased flexibility during this time. They're staying plastic and pliable and flexible just a little bit longer. So there are some benefits to being a slow developer. Now, granted, you have precocious kids. You've got 4-year-olds who are reading Proust, maybe, and who can learn to read on their own. So there are clearly exceptionalities here. And so we don't want to put everything in one, think we have one explanation that fits everything. But in general, not only is slow development characteristic of our species, but some aspects of slow development are characteristic for at least higher IQ individuals of our species.
So as someone who's been approaching developmental psychology from an evolutionary perspective for a long time, could you tell us what is the added value of approaching education from an evolutionary perspective?
Oh, well, I think understanding where these cognitive abilities that we're trying to educate come from, why they're there, why they develop the way they do, can be extremely useful in constructing curriculum, very useful in trying to understand the context in which children are apt to learn best versus when you may interfere with their development. The work I presented here on early education, it sort of gives you some ideas why you shouldn't, what you shouldn't do. This is not a time, the first 6 months or 12 months or 18 months of life for heavy curriculum. So understanding cognitive development, understanding why development it follows the course that it does, the conditions that children learn best in versus not so good in. All of these are enhanced by an evolutionary perspective. At least I have found that, and all of these can be applied to the education of children.
Good. Fantastic. Awesome. Thank you very much, Dave.
Thank you.
Bye-bye.
Okay.